So we are going to do question number both 54 and 55. Refer the graph given below to answer questions number 44 and 45. 44 says, figure shows the variation of the temperature theta with time t of a certain amount of ice initially at minus 10 degrees Celsius when heated at a constant rate. The ratio of specific heat capacity of ice to the specific heat capacity of water. Right. So first we need to take a look at where you have ice, where you have water and all. This is ice. And this is water. This is steam. Now we know where ice, water and steam are. Right. Specific heat capacity of ice divided by specific heat capacity of water. So, how do we find that? Heated at a constant rate, they say. The rate of heat. Q by T is the same. So, we are applying the equation Q equals mc theta by dividing it by the time again. Q by T is equal to mc theta by T. So you can write Q by T for water, for ice. When you write it for ice, it's the same as specific heat capacity of ice. The temperature difference is 10 divided by the time taken is T1. Then we apply the same for water, Q by T. Q by T is same as M ice and C water. Time taken is T3 minus T2. The temperature difference is 100 divided by T3 minus T2. Like this. So you can equate. Once you equate, M gets cancelled. So you can say Ci into 10 over T1 is equal to Cw into 100 over T3 minus T2. 10 gets cancelled. So Ci over Cw is what they want us to find. Ci over Cw value is equal to T1 divided by T3 minus T2. So it's the answer for the 54th. So 10 Ti. And for 55th, specific latent heat of fusion of ice and specific latent heat of fusion of water. So we applied this for here in this one, we applied it for this for ice and this for water, and we are doing the application again for ice and water at these points. Now we applied the equation. I'm going to show it to you. This equation was applied to ice, means applied to this part. This equation was applied to water, means applied to this part. And now we're going to apply to this and to this parts. Right? That's what we're going to do. Right. For ice, for melting, say for melting, Q by T is equal to ml fusion of ice, LF, divided by the time taken, T2 minus T1. For vaporizing, Q by T is equal to mL, latent heat of vaporization, LV, over taken time is T4 minus T3. So again we have two equations we can equate. So when you equate, m gets cancelled. They're asking latent heat of fusion of ice, LF, divided by LV. Which is T2 minus T1 over T4 minus T3. This is the answer.